We thank you, Lord, for your abundant mercies and bountiful grace that you're showering upon us. Thank you for this blessed time to gather and spend time in learning and grasping new things and deepening our understanding. So thank you for giving us opportunities to broaden the horizons of our knowledge. Lord, you have given us wisdom, you have given us opportunities, you have given us talents. Lord, help us to utilize for the benefit of the society, of the community, and to the students, and to each and everyone around us. Especially as we have gathered together today for learning this software MATLAB, help us to understand it in the right sense so that it will equip us, it will equip our students, and also it will help our research programs and to develop ourselves and the whole community. We pray for our leaders, those who are training us, give them the great skill to communicate well and to enrich us with the knowledge. We pray for all the participants who are in this virtual meeting. Lord, throughout all the sessions, be your wisdom and grace shower upon us. We pray for the management and all the top officials for granting us this opportunity and chance to learn this uh, unique unique software. We submit each and everything in your mighty hands. We ask this prayer in the name of our Lord Savior Jesus Christ. Amen. Thank you so much.
Thank you, HN, for the starting prayer. Very good afternoon, one and all present here. I welcome all you for the second day presentation. Today's speaker, Mr. M. Jaffer, is heading team application of engineer. His focus is to train the customers on MathWorks products on their required application. Jaffer brings with him around 15 years of experience in system design for signal processing and image processing. Prior to joining MATLAB, Jaffer worked in a capacity such as center head or training institute of MATLAB, where various courses related to signal processing, communication, image processing is organized. Also help the students to develop project-related face recognition and watermarking techniques. He holds a master's degree in electronics and communication from UIET Kanpur. With these few words, I welcome the today's speaker to take over. Jafar sir, please go ahead.
Thank you, sir. So good afternoon to all of you. So we start with our last session, which has been taken by my colleague, Mr. Anand. So I just want to understand from you that that whether you have some kind of question, concerns, so please type in chat box so that we can answer out those things. You can ask questions through unmuting yourself also, so that we can discuss on that particular topics also. So meanwhile, what we are doing, we are just dropping a link in the chat box. Request you all of to please fill in that particular form so that we can get the idea that what you have did, if you have used that MATLAB on ramp or not, or how we can take in that particular session. So the link has been in chat box. Please request all of you, please open that link and just fill in those details. So link in the chat box. We are again pasting that thing. So did you get the link?
Zafar, I do not see any link, Zafar, in the chat.
No, it is there. It is there.
Okay, I'm not able to see it. Right, let me just see if I have that link, and let me just share it.
Yeah, some people are filling that particular link.
Okay. All right, then I'm not able to see it. Not sure why. No, it's
No problem.
actually not visible to everyone, I guess. Can you just reshare it again, if you don't mind?
Yeah, I'm sharing it again right away.
Thank you.
Zafar sir? Zafar sir?
Zafar, I guess somebody. Yes, sir.
Yes, sir. Please.
He started the presentation. We could not able to hear his voice.
So okay,
No, sir. The presentation is still not started, so we're just waiting for a couple of more minutes, sir.
He told they filled their form.
No, that. Okay, fine, sir. So we can start right now.
Yeah, please start, sir. Maybe if necessary, we can fill it at the end of the program.
Sure,
Or
no
you
problem,
want
sir.
them to finish it before you start the presentation?
Yeah, no problem, sir. No problem. So we are starting. So our today's agenda is like that: introduction to MATLAB. So we get introduced about MATLAB, then we get started with environment and some basic commands, and we have specifically taken a demo for solar electricity production. So with the case study, we see that how we can develop some kind of say program on top of MATLAB, and then we summarize the things, and then some resources that where you can get further say details or help availabilities. So first thing, that what is MATLAB? So MATLAB is a high-level programming language which is used by various scientists, engineers, researchers in their day-to-day work. They perform different kind of tasks by using MATLAB in various application areas. it has a complete interactive development environment so that people who are new to MATLAB, they can start working by importing their data, analyze that data, and get results in the form of graphs in 2D or 3D kind of. It is used for various kind of applications like numerical computation, data analysis and visualization, algorithm development and deployment. So we use MATLAB in such a way. So as session grows, we see that in coming sessions that what different application areas are available to use MATLAB. So with this, just quickly to introduce that MathWorks product family. Right now, what we are doing, we are discussing about this MATLAB, which states at that language of technical computing. On top of MATLAB, that various products are available. People who want to work on math statistics and optimization, we can use that particular area. We can use for database accessing. We can use in different application areas like control, signal, image. If people are working on financial backgrounds or biological backgrounds, they can use that thing. On top of MATLAB, again, that Simulink is also there, which will work as a model-based design kind of environment where, say, engineers or researchers can design their approach in pictorial representation or graphical representation. On top of also that there are various other products are available which we can use. Along with that, we have options available for parallel computation so that people who are working on some big data or some larger problems, so they can fully utilize their systems or HPC kind of systems or GPU kind of clusters. As well as that, whatever the applications they have developed, they can simply port on some kind of hardware. So we support variety of hardwares in which maybe it is a DSP processor, microcontroller, or ASIC devices or PLC devices. So we support various things, so where we can just port out our MATLAB and Simulink products. So this is overall represent that MathWorks product family. So you have access to all the products in your campus-wide suite. So you can just go and start working depending on your need. Okay, so with this, we start with how we are working in MATLAB and Simulink kind of platform. So right now we are discussing about MATLAB. So in MATLAB, what we need to first access that data. From where we are going to access that data could be accessed from some kind of files. So various files are supported with MATLAB. We can just import those files within MATLAB and use that data in MATLAB from different softwares. So like if you want to integrate some software, if you want to call some data from some existing written codes, so you can call those things directly into MATLAB environment. Same way from hardwares. So like I'm just giving an example that if you have an Arduino board and you want to acquire some sensor data from that Arduino board within your MATLAB, that option is available. If you have additional tools available for data acquisition and instrument control kind of thing, so we can import those kind of say specific data within MATLAB. Then whenever we have that data, we are free to explore and discover on that data, that how we need to process on that data. We can develop our own algorithm by using some inbuilt functions or by using some mathematical equations. Like we in our session, we are going to see that how we use a mathematical equation to develop some kind of model. And then finally, we develop such kind of application, which we can share with other users also, colleagues or customers. So for sharing, we have various options, like person who are working on some kind of project, they definitely need some kind of reporting. So they can generate some reports. Person who want to embed their complete design on some specific hardware. So we have such kind of tools available, as I stated earlier. And for deployment, so that you can generate standalone executables or shared add-ins, so that you can embed on some different softwares also. And this whole process is automated so that we can go back in any step and change out our data, our algorithm, or sharing options. And this all could done on top of MATLAB. Okay, so with this, we are getting started with MATLAB. I know that some people have already used MATLAB, so they may know about that thing, or some people has attended last session also, in which also that similar things are there. But we feel that these commands are quite important, which is used widely, as well as that desktop also. So first, we are going to discuss about this desktop, that what is this desktop? Why I'm saying this is a desktop? Because of this consists number of windows. And with those number of windows, they are responsible for specific tasks. Like when we talk about command window. So command window is a place where we can directly input command. So when I go back in MATLAB, we see that how command window is helpful for us. What kind of functionalities are available? Like other window is workspace. So when we call some data, when we process some equations in MATLAB, that all data are going to store within MATLAB workspace, so that you can simply use and access those things. Or your current folder, so which is nothing but a location on your hard drive, so that you can simply pull out some of your data files, some of your MATLAB code from your hard drive. And then collectively we can write down in a place which could be a MATLAB script file or live script file or a function file, so that we can simply display our collective code or outputs. And this ribbon system. So this ribbon system will allow us to find out that relevant functionalities, like to importing data. So like here you are able to see that import data option is there, or I want to work on symboling, or I want to work on parallel computation, or I want to get some additional add-ons for specific hardware. So these all options are available. So whenever we need something, we can simply go on a specific detail and find out those things. Like you are able to see this plots tab, apps, for when we are working on some specific editor, those options are available. So we just need to explore those things whenever it needed. It will be in front of our eyes, so that we can simply use those things. Okay, so with this, I'm just switching on MATLAB, and we starting with some of the basic stuff so that we can get some idea on that. Okay, so like how we are going to insert some kind of array in MATLAB. So there's a simple way that what I should do. Okay, maybe I can write down, simply writing down that a scalar value. When I say that a is equals to 1, it will state that, okay, a is a scalar value, has been stored in variable a, and I'm getting in this place. Now, if I simply type down this value, so inbuilt functionality of pi, so it will give 3.1416 kind of value. And by default, it will take ANS as a variable name. So we need to make sure that we should provide a specific variable name, which is not an inbuilt function or a specific file name which you are using. Because of when you are using some name, it will first look in your workspace. Okay, so whenever we are typing something in this place, so we need to define a specific variable name. Okay, so there are various functionalities are available, as like say, let's say suppose that I have to find out sine of something. Like I say that, okay, what will be the value of sine pi by 60? So I simply get that, okay, sine pi by 60 is 0.523. Similarly, other functionalities are there. Now, how to enter a matrix in this one? Let's say suppose that I say that, okay, I need to input a 2 cross 2, 3 cross 2, or a rectangle, certain different sizes, or a square kind of matrix. So what I do, I simply say that, start writing like this, some values with spaces. I am separating that different columns, and then I am defining that, okay, what is the elements of next row. When I'm done, I simply put up these things. If I need to generate some kind of array, so I can generate some array also with this one. So what I do, I simply say that, okay, starting from 0 and goes to 10. So it will generate some kind of array also for me. If some stepping is required, that also we can define in this place. So I just need to press up arrow key. With this up arrow key, what I could do, I can simply define, okay, I need a step of 0.5 in this case. So you see that right now I'm able to get a step of 0.5 for this one. So similarly, that various different commands are available, which we can use, like some examples we have given in this place. As I said that we can assign output to different variables. So this is must, otherwise it will always store into a variable named ANS. And next time, whenever I define another value, it will get updated. Because of what happened in MATLAB, like you see here, we have generated a value of A. Okay, so A is stated as 1. But when I say that, okay, A is equals to some string. Okay, so what I get next time, A is a string value, not value 1. Okay, so it will be automatically get updated. So similarly, if I simply type that MATLAB, it will be updated in ANS. Like in ANS earlier, what is there? It consists 3.1416. Now when I just type down this, what I get? A string value. Excuse me. Okay, another thing, like what we have seen here, that whenever I'm executing my any of the command, so what is happening, that it is displaying in this place. It is okay if I have single element or say up to 10 element or 100 element, we are okay with that it will display those elements. But if it is 1,000 of elements or 10,000 of elements, it is not necessary that we are going to display all the points into my command window. So for that, what we could do, we can simply say that, okay, I'm just going to call A is equals to MATLAB, or put a semicolon in that place. When I put a semicolon, it will execute my particular syntax, but it will not display that result. But still, it is available in this place. Okay. So one thing I have shown, that up arrow key, which will use to recall a previously executed command. Another thing, that when I want to find out, like we have seen that sine is a function, pi is a function. So if I need to find out some more functions, so what we would do, we click on this fx option. Fx is a function explorer, so that we can browse different functions and we can simply find out and take in our command window that thing. Like right now, what I say that, okay, I need to find out some particular function for sum. So I just say that sum. So wherever I find relevant functionalities for sum, it will list out all the functions related to sum. So what I do, I simply say double click on this sum. So this sum is available for me to use in my command window. Now what I could do, I can simply say that what will be the sum of M matrix, which I have earlier executed. And I say that, okay, I need to define into sum of the variable. So what I get, N as the result of summation. Summation of all the rows are there. Okay, so earlier M is this, so we get a summation of this one. Okay, sorry. One thing we need to keep in mind, that like right now I say that, again I'm calling this N command. Instead of N, I say that cap N. That means now, so N is different, small n is different, and capital N is different. Okay, so we need to make sure that whenever I'm calling some variable, how we have defined that particular variable. And how you are going to check that thing, you need to simply type down this command whose, which will list out all the variables which are stored in your workspace, so that you can get size, class, and you can simply use depending on the need of that variable. Okay, so this whose command will display all the particular thing. Now, sometimes it happens that I have inserted some kind of variable. Let's say suppose that this t variable I don't need right now in my workspace. So what I could do, I can simply say that clear and that variable name. So when I click on, so enter on this one, so you see that t has been removed. If I again check whose, t is not available in my workspace, or I don't want any of the particular function, say variables in my workspace. So I simply type clear and say that clear everything. So it has been cleared right now. Or I don't want to see anything on my screen also of command window. I simply type CLC in my command window, and my complete command window has been cleared right now. So we are starting fresh. So if you want to create some kind of shortcut, so what I could do, I can simply say, select out those particular commands and just, you see that here, I can simply go drag and drop in these places. So whenever I drag and drop, it says that your favorite commands. So you can create some kind of favorite commands also in this place. Like what I did, I just created some of the favorite commands in this place. You see that? Oh, sorry. Here we have written some of the command names, CLC, so that it can clear my variables or some of the outputs also. So clear is a command to clear your workspace. CLC is a command to clear your command window. CLF is a command to clear a particular figure. So when we see a figure, we will see how we can clear out that particular thing also. We have seen up arrow to recall that thing. So these are some functionalities. Like further, if I go in this workspace, so we will see. So as session grows, we will see that different functionalities of different, say, windows right away. So meanwhile, if any questions are there, please put in chat box. My colleague, Mr. Akhilesh, is along with me. He will answer out that thing for you, or you can unmute yourself and you can ask those questions also. Okay, so with this, what I'm going to do, I'm just going to start our demo. So whatever the functions we have, little bit functions we have seen, we see similar kind of functionalities in this demo also. And then we collectively define a report kind of thing with this. Okay, so what I have a picture of one of the building of MathWorks headquarters in Natick, US. So you are able to see that some of the nice solar panels are installed on the roof of that particular buildings. Okay, so what we need to do, we need to work on this particular one, so that we can implement some theoretical say formula for this, so that we can get maximum production of the electricity with this solar panel. Okay, so what we have this mathematical equations which states that sine alpha is equals to sine declination and then latitude, and a complete equation is there. So what we need to do, we need to implement this equation in MATLAB. When we implement this equation, so we need to compare that theoretical maximum and measured data. So whatever the measured data is there and whatever the theoretical equation is there, that whether they are matching or not. Okay, so our goal is like that. So for that, we are able to see that what we have certain things. One is that solar declination and another one is that latitude. So these two inputs right now we need it. Okay, so these two inputs are there. Accordingly, we can compute this particular equation, and with that equation we are able to find out that angle from which angle that panel should be moved. Okay, so we need two things. First thing is that latitude value. So for latitude value, as I said, that it is situated in Natick. So we know that latitude for the Natick is 42.17. Okay. Then angle of declination. So for angle, what we are doing, we are just taking that particular location, Natick, and the sun, according to equator, we are just going to find out that particular angle of that. Okay, so we know that we have two things are available. So what we are going to do, we are going to input these things into MATLAB environment. So we know now that how we are going to input some kind of values in command window. So what I say that, okay, I need to define latitude with the variable name lat, and I just define 42 degree and 17 minutes kind of thing. So how we are going to deal with that thing? So we say that, okay, 42 degree, then I say that, okay, addition of 17, but these are minutes. So to convert that thing, what I should do, I should divide by 60. Okay, so what I get, 42.2833. So MATLAB will store all of our data in the form of in the form of, you can say that double precision value, where we get up to 4 decimal digits, but we are free to change that format if we are working on some kind of scientific computation to a different kind of format, or if we are working on some kind of computational finance kind of problem, we can change that format. Okay, so format and that particular format specifier I can define, like I want to work on some financial computation, so I put bank. If I want to work on long format where 15 decimal digits will come, so I just put format long, so I can go and change that format. Okay, so with this I just defined that declination also, which is 23.45 at that moment. This value I know. So depending on your problem, you must know that what variables or parameters are there for. Okay. Now, so what happened that in this case right now that we have these values in degrees. So what we need to do, we need to convert into radians right now. So to convert that thing into radian, what we could do, we can simply, we can use mathematical formula in which I can use that inbuilt functionality of pi, and we can divide it by 180, so that we can, what we get value in degree. Okay. Now next thing, so you see that what I did, I just use that same variable name. So if you don't want that previous variable to be used, so we can replace that variable, otherwise I can store into a new variable also. Now other thing is that I can use other functionality also, like I say that okay, I need to convert that thing also. One is way is that I said that okay, that mathematical formula is there. Another way is that what I could do, I can simply again go back in this function explorer in which I say that okay, convert degrees to radian. Okay, so what I did, I just typed down the whole thing. You see here what I did, I just typed down the whole thing. So what I get one of the formula as or function as degree to radian or radian to degree kind of thing. Okay, so what I need this particular formula function. I just double click on that, and this particular functionality is available into my command window. Now what I say that okay, I need this to be converted as, okay, and execute that thing. So we have seen that we have two different kind of options available, that we can directly use some functions, or we can use our mathematical equations also. It's totally up to us that how we are going to perform those things. Okay, so next what we want to do, we want to calculate the production throughout the day. So for throughout the day, what we need right away, we need to define from when that sunrise happens and when the sunset happens. So at that place, we assume that sunrise will be taken place somewhere around morning 5:30, and sunset will be taken place around 8 o'clock in evening. Okay, so we say that okay, we are going to define that time variable and say that starting from 5. Now we say as a 5:30, but in MATLAB if I define 5.3, it will be a different value. So we say as 5.5, that means half of that hour. And with that, what I'm going to say that every 15 minutes. Okay, so you see that now I'm defining a step size of 0.25, and finally say that up to 8, that means 20 in the evening in a 24 hours. So what I did, I just generated a sequence of this particular one. Now what I have some time. Now what we need to do, we need to maintain a thing which is, because of we are working on a solar electricity kind of problem, so we need to maintain one more thing, which is local solar time. So we need to compute this LST also before implementing into our actual formula. Okay, so for that, what we are going to do, we are just going to compute this LST as Okay, so what I'm going to do, I'm just going to subtract a particular factor from time, which time sequence we have generated. So I say that t minus 1 addition 2. So whatever the local solar time at that place. So it is 14.6. I'm dividing by 60 that particular thing. So in that case, what I get? So as I discussed earlier also that like I have generated a T sequence, it will displaying all over in my command window, but I don't want that thing. So what I could do, I can simply suppress that thing so that it is just executed that LST has been generated for me right now. Now, whenever I want to see like what is T, I just double click on that variable, this particular variable. Okay, so what it state that T is 1 cross 59 double value, LST is also 1 cross 59 double value is there. Okay, and here we are able to see that all the values are there. Now when I open that LST also, so what I get this LST computed value. Okay, now what we have local solar time available, we have time, we have angles available, latitude available, so we have all those values available. Now what we need to do, we need to start computing that what would be the sun angle at that moment. So we say that, okay, I'm taking a variable name as sun angle and start writing my equation. Okay, I say that, okay, sine, I know that it is there. So I say that sine declination I have to take, I need to multiply by sine of latitude. Okay, then what I need to do, I need to add some factor in this one in which I have to multiply, finding out the cos value of declination. Okay, and then multiply but same factor with sorry, latitude value. Okay, but next thing, so I'm just coming back on the formula itself. What is state that I need to define cosine value of all these values, right? LST and that 15 multiplication and so on. This particular formula is there. Okay, so we have earlier what we have did, we have converted into say a particular degree to radian kind of or radian to degree kind of functionalities. But right now, whatever the values what we have, these values are in again that radian. So what we need to do, we need to convert that thing again. So again, I'm going to choose that same thing, or would I use a different kind of thing? So for that, what I could do, I can simply open documentation from this place. So you see that here, what we have a particular help icon is there, or we have search documentation option available in this place. Okay, so what we are going to do, we are going to just click on this option. So as soon as I click on this help documentation, it will launch a MATLAB documentation, okay, in which I have all the functionalities from MATLAB and different tools depending on my license is available. So what I do, I just say that, okay, I need to find out cosine. Okay, so I say that simply type down cosine. You see that it shows that cos and all those things. So I just click over there. So it will open a complete documentation for function cos. So I want to see that what are the different functionalities are available here. So if I say that what functionalities are available in this place, here that we have different cosine functionalities are available. So directly I have a function named cos d, cosine of argument in degrees. So I can use this function also, cos d. Okay, so what I could do, I can simply go back on MATLAB, sorry, and I start writing, okay, cos, and you see that I just typed cos, and if I press tab key on my command window, it will list out all the functions which are started with cos 3 alphabets, COS. Now I can go and select out that what function is needed by me. I say that, okay, I need cos d. I put parenthesis. As soon as I put parenthesis, what it will do, it will ask me to put some values in this. So I say that, okay, I need to multiply by 15 into that LST we have find it out and subtracted by 12 according to our formula. Okay, so what we get this particular sun angle. So now if I go and open this sun angle, I'm able to find out that complete range of sun angle depending on the LST, the declination and latitude values. Okay, so we can explore by say double clicking on into variable editor also, or what we could do, we can simply create a plot of this also. So for that, what we could do, we can simply select out. So what we need to create a plot. If I only select out this thing, it will create a simple one variable plot depending on the position of the elements. But what I need a versus plot. So what I do, I simply say that okay, T, and I need to create a plot between T and sun angle. I selected out two variables through control and click, and just go in the plots tab. Now here you are able to see that it shows that T versus sun angle. So if you want to change the X axis, you can simply click on this option and you are able to get a different axis. And depending on the data, it will start showing me that what kind of different plots available so that it can be applicable on that kind of data type. But what I need a simple plot. So I click on this plot. You see that it shows that a brief help about that plot. As soon as I click, what it will do, it will create a plot for me, as well as here you are able to see that it stated that thing, plot T versus sun angle. So now we know that if I need to create plot of two vectors, or I need to plot two vectors, this is the function. So I can simply go that and see that thing. Okay. Now we have this particular plot. Now what we could are getting that it is that maximum at this particular time duration, we are getting that maximum power right now. But is it correct? So again, we are switching on slides and let's see that this is the plot we are getting right now. Okay, so what we have, the intensity of radiation due to angle of the sun should be 0 as the sun rises. Let's see that thing. So when sun rises, the intensity is 0, and then further in local noon, it will get 100% intensity. Okay, so that angle has been changed right away. Okay, so what we are getting this when it is on the direct on that particular sun panel, but in Natick it never happens, and some of the atmospheric conditions also there. So we need to keep in mind that atmospheric conditions also. So like this particular formula, that sun incident is 1.4833 into 0.7 to power sine alpha minus 0.678. So we need to implement this in our formula as well. Okay, let's go back and we see that what we could implement in this place. So I'm just closing this figure right away, and I'm just saying that okay, s underscore inc is equals to our formula 1.4883 into 0.7 to the power of, so what we are getting over there in when I go back in an equation, sine alpha, that means that angle which we have computed, sun angle. Okay, so I say that okay, I need to work on sun angle. So you see that I just type sun A, and when I press tab key, it will complete my that particular thing also. So I say that sun angle to the power negative of 0.678. So I say that to the power negative of 678. Okay, fine. Now I'm just trying to execute that thing. Oh, some mistake. So what is the mistake? Reason being that right now we are trying to make a power on this particular one. Okay, which is not a array value, which is a matrix. or you can say that, sorry, not a singular value, it is a matrix or array, one cross something or something cross one kind of details. So what it is suggesting me? It is suggesting me that I need to put dot power on this. That means element by element power I need it. Okay. So by default, it understands that caret is a power, but I need element by element kind of power. So what I'm going to do, again, I'm going to recall that function. I say that, okay, I need to change that value as element by element. Okay. So I just put it with element by element, and I just say that, okay, go ahead. So now I'm good to go with this one. Okay, so now next thing, what I'm going to do, I'm just going to create a production theory variable. So I'm just saying that, okay, production underscore theory, a variable I have taken production theory. And what I'm going to do, I'm just going to define an panel voltage value where energy production I'm getting, and multiply by s underscore inc, this which we have getting in this place. And then now this time I'm just saying that element by element, because if I know that sun inclination and that sun angle both are matrices, so I am going to multiply element by element. Okay, so this time I haven't typed that thing, and I just say that, okay, that sun angle is there. So what I get this thing. Now when I go and check this these two things, and make a plot. So what I get that value for 270 in this range. Now we are good. We have did so many things, but if I need to represent and showcase those things, what we would do, that we have seen that we have input multiple commands, we have used a workspace, but how would I display those things? So better, what I could do, I can simply use those functions. Like I need these all functions. So I'm just taking all the functions right now. Then later on, I will change those things. So I just select out all the functions and just say by right clicking, now you are able to see here that we have various options, that create script, create live script, create favorite, or error indicator kind of thing. So I say that I need to create a live script for this. So I just click on create live script. So as soon as I say that create live script, it will open this particular live editor window. So anyway, you can open by going into home tab, and here that option is that new live script, and you can manually copy paste those things, or you can simply say, what happened that? Okay, so I'm undocking right now, maybe some issue. Yeah. So, okay, so this is my live editor. As I shown that that thing that we can go and create a new live script, type down or copy and paste those things in there. So what we could do, we can here. So this thing my colleague Anand already told that thing at that day, but to brush up that thing, what we could do, we can define, okay, I need to put up some kind of text in that place, and this is my title of the file. So I say that solar electricity production. Then I need to put some kind of normal value that this is a demo code, some values. What I need that after this line, I need a section break. So I say that, okay, section break would be there. And here that I'm going to compute some different values. So I need to remove some of the functionalities. So I'm removing all those things, and this error thing. Oops. Okay. Okay, so now what I could do, I can put some section breaks so that I can get some kind of say plot with this one. If I need to input some kind of text, if I need to insert some images, those options are available. Like here, you're able to see that I can insert some images. I can put some equations also. So if I need to put some kind of latex equation, I simply say that, okay, I need to insert some equation at this place. So I say that this is a text place and I need to insert some of the equation here. Okay, so what I could do, I can simply type down my equation by using these symbols and all those things. Okay, so now what we have did, we have just inputted those all values and created a file. So for time's sake, what I'm doing, I'm just opening a new, a ready file, which we have created earlier. So in which we are able to see that we have inputted some of the text as well as that some images and whatever the values we have used earlier. That okay, so what I'm doing here, I'm just clearing all the outputs from this place so that we can simply see those things. Okay, so these things we have already did. Here we have generated, we have computed local solar time. Now you see that here what we did, we have defined that equation. Now how we have defined, I have shown you that equation portion, but this is latex equation. So we can just simply input some latex equation also, so that my documentation will look nice. And if we are presenting or giving to some student as assignment, they can easily understand that what kind of formulas or equations they need to input in that. Okay, so till this particular portion, we have did this thing. Now here you see that we have did some kind of annotation also. Okay, so we have defined that what is the time of the day and production and some titles also. So like if I start executing, so can anyone tell that thing that how we are going to execute these cells? If you recall your last Tuesday thing, you can type in the chat box. Okay, run. Somebody said that run. From how we are going to run that thing, run section. Okay, so because of run will execute my complete file, or this option is there, run section. So we can use this run section if I want to execute only this particular section where we have put it a section break. I have better option that you see that nice blue line has been shown here. When I hover my mouse at that place, it will change into a hand icon. And if I click over there, it will execute that whole section for me. Okay, so first section, second section, and the sun angle, I'm just going to find out what is the sun angle. And the best part of the live script, you will see that if I hover my mouse in any of the places, it will start showing me that values also, whatever the values are there in my workspace, and my output, that what is the graphical output for that. Okay, so we have seen up to this place. Okay, so what we have did, we have just whatever the theory production theory is there, accordingly we have just find out the minimum from production theory and 207. Why we have limiting? Because of we need to introduce an inverter limit, that how much inverter is going to handle at that moment. Okay, so now what next we need to do? We need to compare with the recorded data, that whatever the things I'm getting on that particular day, whether it is working perfectly with the recorded data or not. Okay, so for that, what I'm going to do, I'm just going to import a file from June 2018. So how I'm going to import that particular file in MATLAB? So what I could do, I can simply go back again in MATLAB, and I am not liking this messy command window, so I'm just clearing this workspace. Now what I have this solar production.excel file, which is nothing but containing some time stamps. So in every 15 seconds, this is showing me that all the details. Now here that 2 solar panel values has been shown in terms of voltage. Okay, electricity production is showing right away. Okay, So I'm just going to call this file within MATLAB. Now, how I'm going to call that thing? Either I must know about some functionality, or I must have some kind of interactive tools which will allow me to do such thing. So what I could do, I can simply click on this import data. Now you see here that import data option is there. Or what I could do, I can simply say right click on my Excel file. Here also I have this import data option available. Okay, so whatever the way you choose, you can go through with that. So I'm choosing this option so that I can show some more things to you right now. Now, when I open this particular option, it will show me that all the files which are supported and currently in my current folder right now. So it says that it can import text file, it can import Excel file, or it can import various other file formats also. Okay, so many file formats are there. So I just say that, okay, this XLSX file is going to import into my MATLAB workspace. I say open. So as soon as I say open, it will open into a spreadsheet wizard, which will allow me to import certain data within MATLAB environment. You see that all the data points, timestamp, and that solar panel names has been given in here, and some name has been given in this place. So I say that, okay, I don't want to say import with such lengthy name. I want to change it as a different name, production. Okay. Now we have certain other options are available. We can choose out that what range I need to import if I don't want to import, because of this is consists 2880 values. So for a complete month, every 15-minute value per day is there. Okay, so we have somewhere around 200,880 values. My variables has been defined in first row, so which has been defined in this place. How my data is going to call into MATLAB environment, so we are free to choose that thing. I prefer table format because of I need to import only one variable, which will handle all kind of data types, whether it's numeric, date, or text, whatever it is. So I prefer a table format. Depending on your problems, you can choose any of the formats which are displaying in this place. Here some options are there, that if some cell is empty, sometime it happens that some readings are going to miss. Okay, so what you could it could do, it will automatically change that reading with NaN. Because of removing that complete row might affect on my whole data, so it is going to say change with NaN, that thing. Okay, so what I do, I simply say that okay, green button, and it will import that thing within my MATLAB workspace. So if I go back again in MATLAB, you see here this this particular production tabular data is there. Okay, timestamp, it has a name AH3, that's a solar panel names has been given. But right now I have imported only for one particular file. Let's say suppose that you have such number of files available. So what we could do, we can simply go back again in this place, and you see that here we have some option that we can generate a live script, a MATLAB function, a script file. So if you want to hardbound for a specific file, we can use any of these two options. If you want to create a customized function which can be import such similar kind of other files also, so I just simply click on generate function. So it will generate a function. You see that it states that clearly that it is generated right away at this moment itself. Now what I need to do, I need to simply just given some name in this place. Next time I just use this file to import any of the similar kind of file within MATLAB. Okay. So now what we have, we did similar thing. We use a function. So if I don't want to use that thing, I can simply use that read table. But read table is used for only for one file at a time. Otherwise, I need to make for loop and all those programming stuffs we need to do. So this all has been reduced by this single file. Okay. Now, with this, what I'm going to do, I'm just going to use this particular production variable, which I have. Now, here you're able to see that we have written production.timestamp. Now, what is it? Now, if I again go back in MATLAB, sorry, I'm closing this, and I call my production variable. Okay, and I put dot. So what I could do, I press tab key, it will list out all the details of that table variable. So AH3, we know that it's a column, LS parking is also a column, and timestamp is also a column. Remaining three properties of the table, how many rows are there, and what variables are there. So what I need timestamp. So I just say that timestamp. So what I'm doing, I'm accessing a single column from a table. So simple way is there, just a variable name which I have called, put a dot character, and whatever the names are available for the variable, I just simply call that thing. So what I did, I just simply call that in this place, and we are plotting this and giving that, okay, dates are this and this. So what we are getting now, you see here that whole month data has been plotted. So if I say, okay, on 21 of June, what will be the data look like? So I say that, okay, start zooming. So I'm doing interactive way also on the live editor. So you see that on 21st of June, when it started, it shows that sun is hiding behind the clouds because of it's not quite sharp as it shows on June 19. Okay, so what we need to do, we need to work on. So let's say suppose that I need to display this plot only, so I can use this code to update onto my current thing, say section also. So you see that it automatically change my code here also. So it's totally up to you that what kind of display you want. So on summer solitude, that means 21st of June. So what we are saying, that X limit which we have shown right away. And same way, if I go back again and see that what is on 26th of June, sorry. If I say zoom on this place of 26th of June, so you see that on June 26th, it's quite smooth. Okay, rather than that cloudy day kind of thing. So we have zoomed that thing for June 26th also. So what we are going to do, we are just going to take that particular thing. Now, again, I'm coming back on presentation. So what happened that, you see that I have a whole month data, all 30 days data for the June is available. As I said that earlier, that 2,880 values. Now what we need to do, because of we have a single column available. So we need to change that thing into a matrix. That we know that in every 15 minutes we are counting on a particular data. So 96 data is available for single day. So we have a total 96 cross 30 kind of matrix to be required to process the such thing for that everyday data. So what we are going to do, we are going to reshape. So direct function is that reshape. Like I have used reshape. If you are using some kind of functionality and you want to check out about that, what is this function? So what I could do, I can simply right click on the function and you see that it shows that help on reshape. Okay, so what it will do, it will launch a reshape kind of reshape function help, that how I'm going to use that reshape. Okay, so what it says that I need to provide my matrix and what size I need it. So as I said that my matrix is production.ah3 and 96 cross 30 is my matrix size. So I just extracted, and then further what I'm doing, I'm just calling the data for 26 June, because this is a whole June data. I'm calling for June 26 day of interest. And then finally, what I'm going to do, I'm just going to find out time. As I said that every 15 minutes this reading has been taken. So starting from night time 12 to every 11:45, and then every 15 seconds. And then we are plotting that particular data. And here what we are doing here, just we are comparing against the theory. Okay, whether it is showing perfectly to us or not. So what you see here in this place, that this particular say full day plot, okay, of 26. Okay, now when I go and compare along with theory data, which we have created earlier, with that theory data, it is quite matching with that. Okay. Now, earlier we have seen, if we go back over there, we have seen that 270, that peak is gone for 270 at this place, right? So why it is happening? Again, we switch in presentation. Now you see here what is happening, that we are getting direct sunlight from on the solar panel, and what we are getting a voltage of 270, but inverter is limiting to 207, and we are getting a 207 a DC line on that in house. So that's why what we are it is doing, it is just showing this kind of curve to us. So inverted limited data is showing. So it's quite matched with the theoretical maximum, which we have performed through equations and whatever the measured data is there. So what we did, okay, I'm just quickly coming up on this one. So what we did in this example, we just taken some equations, theoretical equations. We figured out that theoretical equation, that how that data look like. Then we take that actual data, real data, and with the real data, we have compared that how it is look like when we compare those things. In that, we use various functionalities on MATLAB also. Okay. Now, what other things we can do? Like earlier, I said that we can support various kind of different files. So we are able to see that it can support various different files, different web services, different applications, and other hardwares also. So you can simply import those data within MATLAB environment. Okay, so like when we talk about images, when we talk about signals, so we are going to cover up such kind of images or signal kind of files within MATLAB. Okay, same way if you want to perform some kind of data analysis. So like in week 3, we are going to discuss about mathematical problems, statistical problems. So where we are going to talk about data analysis kind of things. Some visualization. So like right now we have just only seen today itself that a visualization of a 2D curve. In week 2, day 1, we are going to see that various different kind of plots, like a 3-dimensional plot, or how we are going to annotate that thing. So those all things we are going to see in that case also. Explore and discover. So like right now we are working on MATLAB itself. On that day, we are going to work on statistics tools, curve fitting, or let's say suppose that next day image processing or signal processing. So various application tools we are going to use to process similar kind of data. And then we can share, like right now, whatever I have did in this particular file, I need to share maybe from all of you. Okay, so what I could do, I can simply just go in this export option. In this export option, you are able to see that here that various options are available, like PDF, Word, HTML, LaTeX. So what I could do, I can simply click on export to PDF. What it will do, it will try to export that complete file as a PDF. So I say that, okay, save this file, so that we are able to see that what kind of PDF file has been generated. Meanwhile, it is generated. Let's the presentation. Other options are there, like you see that this particular file has been generated in the PDF form. It has code, it has images, it has all the outputs, and everything are available in this place. So you are free to distribute to other people. Sometimes it happens that you don't want to share your code, you want to share as an application, but some people want to use on top of MATLAB, some people want to use without MATLAB. So those options are available. You can create MATLAB apps also, or you can create standalone executables or shared add-ins also. So as session grows, we will see in next coming weeks those kind of things also. Sorry. Okay, so in summary, what we have seen, that MATLAB is a high-level language which support different vectors and matrix kind of operation. Various mathematics and visualization functionalities are available. We have a complete development environment. Like right now, we have seen only live editor. At that day, Anand shows app designer. Similarly, as I said, that various products are available, which we are going to see in coming weeks, like signal processing, image processing, controls, or Simulink. So those things we can see. Similarly, like statistical machine learning or deep learning or curve fitting kind of problem. So we see as session goes specifically. Now, one thing quickly, just switching on displays. So I have seen that some of the people already use that thing. Like if I go in this place, somewhere around 12 per person has completed that thing, and 52 people had completed but started but not completed that thing. But 41 people haven't started this MATLAB on RAM. So this is a place. Sorry. So this is a place where you can simply go and do a hands-on kind of thing. So you need to simply open or search MATLAB on ramp on the Google, and you are able to find out first link, go through with that link, and log in with your institute domain IDs and complete this particular task. It will help out you understand that what basics about MATLAB, so that in subsequent weeks, whatever we are going to cover up, you are easily go through with that thing also. So like right now here, you are able to see that some task has been written. I need to perform some of the operation 3 into 5. So as soon as I start, okay, 3 into 5, it find out and give results. If results is correct, it says that, okay, you can proceed to next step. What it's saying that again, that, so which I have shown a little bit, but similar kind of things are available in this place also, but with the hands-on. So like right now, m is equals to 3 cross 5. So instead of m, what I'm going to do, I'm just going to change this value to n. Let's see that what it says. So as soon as I execute, it says that it is wrong. So you need to try again that thing. Okay. So it will help out you in understanding the basics of MATLAB when you complete this 2.5 hour kind of course. So it is not necessary that you can complete in one go that thing. You can complete in multiple stages also. Okay. Rest that this desktop consists so many functionalities. Just we have covered up little bit functionalities like these. If I want to analyze my code, whether my codes have some kind of errors or say warnings available, so I can simply use that thing. I can simply choose run and time so that we can find out that where bottlenecks are available in my code as soon as you start writing your codes. Or to show if your students are working on some kind of projects and their say programs are like taking some time, so you can simply find out that where their codes are taking some time. Now how you get all those things, for those all things, this documentation is there. In that particular documentation, these all details are available. Like if I go in the documentation of MATLAB, under these all sections, you are able to find out all those details. So there are two ways. One way is that we can simply go and complete this on ramp. Whenever we need some kind of help, we can simply go and choose out this documentation, which is available. Apart from that documentation, a proper user community is there. So you simply go and access this user community in this place, so that you can ask some questions from users from worldwide, as well as MathWorks representative also able to answer out your questions. So with this, I just want to take questions from you. I hope my colleague Akhilesh is answering all of your questions when you are typing in chat box. But if you have some specific questions, you can just unmute your mic, or you can type down in the chat box so that we can go ahead with that. Okay, what is the assignment for this week? It is starting on MATLAB. Okay, so what is the assignment for this week? It is start working on MATLAB on RAM. Yes, so this week everyone has to complete MATLAB on ramp so that you can get a certificate, because of later on we have to submit those things. So you must have those certificates after completion of MATLAB on ramp. So for this week, this MATLAB on ramp is only that thing.
Jaffa sir,
Whether, yeah, please.
actually, that many faculty are new to this MATLAB. Can you help them how to give some example to write a program and how to save it, how to save the output as a PDF file once again?
As a PDF file once again?
Yes, yes, yes. How to use the MATLAB Drive?
Okay, so MATLAB Drive kind of thing.
Yeah, yeah.
See icon at this place. Okay, so here that three folder icons is there. Middle one is that MATLAB Drive. So when I click on this MATLAB Drive, it will try to access my MATLAB Drive to current folder. Okay. Okay, so it is trying to access my MATLAB Drive. What's happened? Just a minute, sir. So MATLAB Drive is just a place where you can store your programs, and you can access through MATLAB online. So like one thing I have shown this MATLAB on ramp. Another thing is that this matlab.mathworks.com. So this is online MATLAB. So when you want to, just a moment, sir. So when you want to use your some program in online or offline mode, so you need to use MATLAB online. So like here you see that when I open this thing, by default it is going to store everything in MATLAB online. MATLAB Drive. Okay, but when we go back in this place, you see that it is opened my MATLAB Drive at this place. So whatever I am able to see here, I am able to see in this place also. That similar things has been shown in this place also. Okay. So how we access those things? So whatever the code you want to write, whatever the things you need to perform, you can simply say write in a particular file. Like right now, what I'm doing, I'm just saying that okay, so I need to create a file in which I'm just using some of the inbuilt functionalities, in which I say that okay, t is equals to some values from 0.25 to, let's say, 100. I said okay, and then I say that okay, s is equals to some value of sinusoidal value of t, and I simply say that plot of t comma s, and say that x label of it is t. You see that as soon as I am typing, this live editor is helping me. Okay, so I'm just putting some of the text so that we can simply get better idea. Now when we are done with this one and we need to save this file, we click on this save icon. Okay, save on this, and then what I could do, I can simply choose. You see that by default it is showing MATLAB Drive because of it is my current folder right now. So I say that okay, I need to save this file with the name of test, some name I have to give. I just given test script and say that save this file. Now I'm just running this file with a section, or run whatever the way you prefer. So like right now I'm run this thing, I get this kind of curve right away. Now what I need to do, I need to say generate a file, say PDF file or Word file or whatever the options is required. So I need to go in this export option. You see this export option is there. So when I click on this export option, you are able to see that PDF, Word, HTML, LaTeX, these kind of options are there. So what I need, let's say suppose that at this time I need a HTML file or PDF file. The way is same for everything. So I say that okay, I need to generate a HTML file for this one. It asks me to store that file in some location. Like if I'm working on MATLAB online, I have no choice. I need to store in MATLAB Drive. But if you are working on your desktop MATLAB, you are free to choose anywhere. But right now I'm just storing into MATLAB Drive that thing. Okay, so I say that, okay, store with testscript.html, that same name I'm choosing and saying save right away. So you see that HTML file has been generated and opened into my browser. Okay, I have this MATLAB open here also, and this testscript.html is available. Now what I could do, I can simply say, okay, sorry, not from this place. What I could do, I can simply say that drive dot mathworks.com. Let's see what comes. So I say that drive.mathworks.com. So it is opened automatically, or drive.matlab.com. So it is showing me that all the files. So if you are using Google Drive or OneDrive kind of thing, it is similar kind of say approach. Now here my file is there. I can simply just select and click on download option, or I just right click and say that download this file. So let's say suppose that I say that, okay, download this file onto my desktop. So this HTML file is downloaded on my desktop. I just go and see that it is on my desktop. So I just open my desktop, and in desktop, where is that HTML file? Yeah, this HTML file is there. So I'm just saying that, okay, I need to open with any of the browser of mine. So this HTML file with me. Okay, so when you are creating some kind of file, if you want to store on Drive, you can store in that Drive, and when you want to access that thing, you need to simply go on either drive.mathworks.com or drive.matlab.com. It will say point out you in drive.matlab.com in this place always. But okay, so what I'm doing, I'm just copying this link and putting into chat, so that if you want to access, you can access that. Okay, as well as that for MATLAB online. So I'm putting in chat itself, and on-ramp course. Okay, so these are the links to use MATLAB Drive or MATLAB Online, or say MATLAB Online. Okay, any further questions?
Zafar sir, what are the other advantage in MATLAB online facility? Because many faculty could not able to download because of the compatible issue. Many will like to use MATLAB online. What are the advantage and what are the disadvantage in this download while downloading a file of that option is there, no? Can you please explain the difference? What is MATLAB online and the desktop?
Okay, so MATLAB online is a beta kind of version of same MATLAB, where we can access MATLAB and selected tools with particular functionality. Like right now that this is my online MATLAB, and if I type down we are in this place, so you see that it shows me that certain functionalities which are supported. Okay, sorry. Just a moment. MATLAB online. So when I go in this place, you see that it states that what things are supported. Okay, specification and limitations. So you see that MATLAB is going to have this kind of limitations. Simulink has these kind of limitations, and whatever the products has been written in these places, these products are only supported in MATLAB online, not all the products. Like if you want to generate some kind of code, you are not able to generate some kind of code over there, C code or HDL code. But for a person who is starting new in MATLAB, or they want to work, their students could start working on MATLAB, for that MATLAB online is good enough. And MATLAB Desktop, definitely it has full-fledged functionalities. All the tools and everything is available depending on your platform. So somebody is saying that sometime I get the message that you cannot save docs in C drive, store is it in owner folder. What is it? Because of you are using MATLAB, but you are not an administrator of that system. And C drive requires administrative privileges. So that's why it is required. So better you can store in some different drive, or you can say that in documents folder or in some specific folder which you have created, or you must be admin of that machine. I get an error message that the path is not correct. What is the reason? So can you please elaborate, Mr. Okay, the same person, that Saya Lenin. Okay, so can you explain the vertical of MATLAB? What do you mean that by this limitation? How to go for assignments links? So you need to simply go and open this on-ramp thing, matlabacademy.mathworks.com. I have, I'm just copying it again. matlabacademy.mathworks.com. Okay, so this is the link to perform. You need to go on MATLAB on-ramp for this. Oh, sorry, my mistake. I just typed down somewhere else. You are not able to unmute. I think so. They have.
Zafar sir, you can share your email ID and cell number so that they can ask their doubt personally to your email ID.
Yeah, I'm typing in the chat that my mail address. Okay, so we are sharing a feedback form for this particular session. Please fill in that particular feedback. So I'm not sure about this, that we are able to assign.
Jafar sir.
Yes, sir, please.
Jafar sir.
Yeah, please, sir.
Please give permission to everyone to unmute their mic and ask their doubts.
I'm just checking that I'm not able to get that in
Please
this.
ask Harris. I'll call Harris sir, because our higher officials would like to ask questions, trying to interact. They could not able to. Kindly permit him. I'll also call him Harris Mathurs.
Yeah, I'm just looking, sir, meanwhile. Yeah, I get that, sir.
Otherwise,
எங்களுக்கு அது ட்ரைனிங் கொடுக்கிறதுக்கு ஒரு ரெடியா
certification
He's a
pending
very
one
nice
year.
boy.
Nobody can
Even
able
like
to
no
act.
person. That is the reason I always like no.
Person
இடத்துல அவனை keep பண்ணுவேன் நானு. செஞ்சா அவனும். Then I feel like
இதுல வர கதைங்க நடக்குதுங்க எல்லாம் கும்பிட்டா.
he does not know that he is doing a mistake. Without knowing, he will do some. பண்ண வைவா கேன்சல்
இந்தியாவுல வேற வேற
காமெடி பண்ணிட்டான் அப்ஜெக்டிவே சேஞ்ச் பண்ணிட்டான் இதுதான்
based assessment.
சாப்பிட்டுட்டு take a rest 6 o'clock 6:30
What are the any lab that you are teaching?
ஒண்ணுத்துல ஓபன் பண்ணி வச்சிருக்கேன் உங்க வேற ஒரு டேப போட்டு ஓபன் இதுல உங்க பேரு யார் பேரை போட்டாலும்